Hey everyone, and welcome back to this module where we'll be looking at some tests in performance between the blueprints and the C++ logic by referencing some existing and popular comparisons that have already been used in the past. Then we'll also have a quick look at how some of these tests may not always be entirely relevant for many of the projects that you'll tend to be working with. Although C++ is definitely more performant, it is worth discussing whether that should always be a primary focus when you're deciding on what to use. So I have a temporary project loaded here. You don't need to use this one. I'm going to run through what the code is providing, how it's working, and just some of the basics around the code. This is an example heavily inspired by Alt on YouTube, who's done a C++ versus Blueprint comparison in the past. I've made a few changes to the code just to hopefully make the Blueprint a little bit more performant, to bring it a little bit closer to C++ for fairness, and also just exposed a few extra things to the editor so it's very easy for testing, and I'll kind of show you what is happening just so you know that nothing is really hiding or obfuscating anything in the code. So the first and most important thing is we have a BP underscore example base. This is the base class all three of these are using. The main reason I've done this is that this has a blueprint interface, the BPI underscore generic, which is allowing me to communicate with the widget blueprint here just to set how many loops this logic will be undertaking. So that's the main reason we've got a base class. All of these classes, though, are derived from the test CPP class. All of this is derived from a base C++ class. So this is going to allow me to do some tests purely in Blueprint, some purely in C++, and also we have here an example mix of Blueprint and C++, so you can get quite a good idea of how merging some of the logic together can still be easier maybe to edit in Blueprints, but also save you a lot of performance just by doing half of the work in C++. So let's take a quick look at what's happening in the C++ class. So we've got two functions here. We have the get total sum and the sum functions. Both of these have been set as U functions and made Blueprint callable, again, just so that these can be accessible in Blueprints. Just realized now that I probably could have made this a little bit better by turning off the event tick, but that's fine. This isn't really aiming to get the performance as low as possible. As long as all of them have the event tick enabled, this should be pretty fair. But what we're doing is when the character will be overlapping one of these interactive classes, we are running through the get total sum. It's going to be called first. That's going to loop a certain amount of times depending on what I've exposed in the editor widget I mentioned. And for every one of those loops, that's also going to add the total sum. So calling that function to add and loop through a certain amount of indexes there as well. So this will return the total number of times that this is looped through to get that sum. And it will also be printing out how many milliseconds it took to get that complete. So the way that we'll be doing this is, let's just take the C++ pure example first of all. So we're getting the current time and storing that as a variable as soon as this is overlapped. We're running that get total sum, so that's calling the C++ version, which will of course call the sum C++ version. And then once all of this has been done, the only thing we're doing in Blueprint is we're using a print string. And again, I've just exposed this in the base class. I only need to do this once. And it's just taking whatever the time was when it was initially set minus the current time. So that's going to get our milliseconds. And it will tell us how many times this is looped and how long that took. Then for the pure Blueprint example, this is very similar. This time though, we're storing the result here. We're getting the time. This time I have a Blueprint function of the get total sum. So this is called get total sum BP. So we know this is all happening in Blueprints. This is then going to again loop through depending on how many times I've put in the editor. We're going to add this together. And this is the bit which I've changed slightly. So this has been turned into a pure function. So this should be a little bit more performant, a little bit more like how this is working in the C++ version compared to the original test that I've referenced this from. But then this is just doing a very similar thing again. So we're truncating our return, we're looping through this, and we're adding the sum together. And then finally, back on the event graph, we're just printing everything out. So I've just added different colors as well, so we know which one is which, and we're just getting the time in printing. Then finally, just so you've got an idea of what this is doing when we press play, and we will be getting to the play button soon and seeing the interesting results. But what we have here, we have our example mix. So we're doing half of the looping in the blueprint class. So this is essentially the generate function, but just housed in the event graph. So we're looping through a certain number of times based on the loops. We're then calling the C++ sum function. We're getting our result. And when this is complete, we're doing our print string the same as everywhere else. So we're only doing a print string once when the for loops are complete. That's the other thing to note here. So that brings us to our example. Now I'm going to start something low. Let's just say something like 10 loops. And like I said, all this is doing, I'm just setting the loops here, and all three of these now have used the Blueprint interface to update this. So I only need to make that one change. So if I press play, we can run through these and we can see that all of those took 0 milliseconds to do 220 loops. So at this point, on a very low number of loops, is actually very, very even what we're getting here in terms of performance results. From the tests I've done, I know that I can take this up to about 40 or 50 loops. So I'll just change that before Blueprint starts lagging behind. So it may seem like a small number, but if you think about kind of general programming and the kind of things you'll be doing, it's very rare that you're going to be doing 40 times 40 loops for a for loop and to get this many results. So let's take a quick look. So at this point, we're doing 11,480 total loops, which is just insane. You very rarely, as far as I'm aware, need to do quite that much on an immediate overlap. And you can see that it still only took the blueprints 1 millisecond. There was no lag. It's still relatively kind of performance acceptable there, at least. Maybe not friendly, but acceptable. And there we go. I just finally got the result there. There are certain instances, depending on when this is run, that you actually still get 0 milliseconds returned. So it's still almost comparing to the other examples. So now let's bump this up quite a bit and see what we get at 200 loops. Okay, so we're now doing an insane number of loops here. And you can see that this is where the big performance hits are really coming into play. So we've got a whole 19 milliseconds that it took for the blueprints to do that, and the C++ and even the C++ mix are still returning 0 milliseconds. So again, this is kind of showing that mixing the two together can really kind of balance that performance to usability. Now, at this stage, I know that I'm quite close to getting this to crash, so I'm going to go to about 500 loops. Anything more than this, and you tend to find that blueprints will just kind of completely crash and not return a result. And the thing to note there is that it actually lagged. At 117 milliseconds, it actually lagged. It was very visible that that was taking a performance hit. The mix is now up to 2 milliseconds. You can see that there is definitely going to start being performance hits, even if you're using that mix. And I just kind of want to show you the crashing of this as well. So let's set this up to something like 1000. And there you go. You can see that it classes that as an infinite loop. Although if we just do that again, but without touching the blueprints, we're still getting 0 milliseconds in C++, only 3 milliseconds in the mix. So again, still doing a lot of loops here and handling that quite well. But definitely, there's no argument that C++ is going to be the most performant approach. Now, the reason I wanted to go into this, as this is, like I said, this has been done in this form and a few others on YouTube and around different forums and things, comparing this to get an idea of the performance benefits. And I kind of wanted to do something like this myself, but if you look at the alt page on YouTube, which did the original test of this, there is a kind of C++ versus Blueprint war going on in the comments, which is why I ended up never uploading anything like this. That's the kind of mindset that we want to get away from. There isn't a versus or a side to be on. It's just knowing when to use blueprints and when to use C++, because you have to remember that it's very rare that you're going to be told in a game or in an application to run through 1000 loops 1000 times to apply a sum to some value. And this is what I mean by some of the tests being done. They're very good at showing the performance and sort of how they perform against each other, but they're not always too relevant in the kind of development approaches you'll be taking. To the point, in fact, if you're doing something like this, you've probably gone wrong somewhere and have made a mistake anyway, and should probably revisit your code. That being said, there's also other things that we haven't discussed, not so relevant to the way that we're trying to approach this project and kind of fixing and cleaning up an existing project. But you do also have things like the blueprint nativization. So that again would mean you could do a lot of this in Blueprint and nativize that code into C++ when you build the project out. So again, that will do that heavy lifting in the maths inside of C++ code rather than Blueprints, and the performance again can be quite good there. But the main thing is I think doing it this way shows quite an interesting topic in that this has been a good mix of Blueprints and C++ just in this example. So I have blueprinted a custom widget that I can just drop into the content browser here. This is allowing me to quickly get the number of loops and iterations that I want each of these classes to do, which is then being updated in a blueprint interface. So again, allowing me to just do something once. I don't need to recompile anything. This allows very quick and easy demonstrations as I've shown here. And then we can see all of this code is also transferable into C++. Taking the parent C++ class, we have access to all of the variables and the functions if and when we need them in their blueprint children, which you wouldn't get the flexibility of if you were to do it the other way around, of course, starting with a blueprint class, going up to C++, the C++ isn't aware of the blueprint version. So it's always important to remember as well which way you are defining things. If you want functions or variables to be reused between Blueprint and C++, it needs to be created in the C++ class. And then this also touches back on topics in the balancing Blueprint and C++ documentation that I've shown you, where it specifies that things like maths executions, iterative loops, things on the event tick should be dropped into the C++ class for reasons like this, because it can do an insane amount of extra work on top of blueprints if that is absolutely required. And generally, like I said, a lot of games actually don't need that. And this is where you may need to kind of reconsider if you need to go in like C++ heavy to begin with. A lot of single player games, a lot of even things like platformers and racing games have been made purely in Blueprint and are more than performant running at 60 FPS on standard kind of desktops or even some consoles. But definitely things like networking games or online games do need that extra computational kind of power from the C++ side of things. And again, we'll be getting into more of those examples in future modules when we look at some more of the less talked about strengths of using C++ as a kind of development approach where applicable. So in this module, we've seen some basic examples of where C++ can outperform blueprints, but how it shouldn't always be an immediate concern for many of the projects that you're working on, as long as the code that you do place in your blueprint classes is well thought out, structured, and performant. Just remember that bad code is bad code, whether that's written in Blueprint or C++ at the end of the day.